Hello, everybody. Welcome, welcome. For those of you that responded to my Survey Monkey, I totally appreciate it. And I could see the first 50 responses for free. I'm not going to pay extras to the rest of them, but I think I got what I needed. I've learned what I need to know. You want more bang for your buck. You show up for a Zoom, you want points. I'm understanding that. And also, some of you don't love Jamboards. That message came across loud and clear. But Jamboards love you and they're good for you. It's like eating your vegetables. Okay, so tomorrow I'm going to open the exam. And the exam is 20 questions, 60 minutes, it's 100 points. Not all the questions are weighted the same. And because time, and some of you have accommodations, and I will honor those accommodations. If you have time and a half or double time, don't worry, I will take care of that. But for some of you, it's going to be, you need to know the chemistry and you need to manage your emotions and your time. So I want to talk about how to manage your time best and also how to not be a cheater. Because I know that you want to be a scientist, and scientists pursue truth in the physical realm in an honest manner. And there are temptations when you think about the points on the line, but I want to tell you how to be both full of integrity and maximizing your points. And this is how. When you take the exam, even though it is open note, open book, it is not open friend, open Google, open tutor. It is not open previous assignments or Zooms. It's just open book and open notes. You don't want it to be open book. You don't have time for that. What you need to do is lay out your notes. And so right now I just want to talk about what kind of notes you need. And you're welcome. So thank you for showing up. You definitely want a periodic table. Of course, you need your calculator. You're going to need pencil and paper. And then you want some example problems. So you may be thinking, I don't know, Sue, what kind of example problems do I want? Let me tell you. You absolutely want to have that periodic table where you colored it red, blue, and purple. You absolutely want that page of this symbol stands for this element. You definitely want some examples of things like, I don't know, conversion problems. What kind of conversion problems are there? It could be volume in one system to volume in another. Length in one system to length in another. If I'm going too fast, slow me down. You are definitely going to see a rate, like meters per second to miles per hour, or miles per hour to meters per second.
Sue,
yeah.
sorry. Do you have a list in front of you? I didn't catch what you said right after the colored periodic table. No? Okay, sorry.
Symbols, what symbols and elements, like what symbol equals what element.
Thank you, Madison.
That's Melissa. We have two Madisons.
She can't see me.
Thank you, Melissa. Sorry.
Yeah, that's fine. I'm speaking for Melissa because I know her. She's lovely and she's got a generous heart. Right, Melissa?
Today, yes.
It was a good day. Okay. But you definitely want to have examples of conversions because, the conversion sheet. You absolutely want the Chem 1A conversion sheet, the allowed conversions. If you start spending time Googling things like how many square inches in a square foot, first of all, you're going to lose points for that because it's not on the sheet. And secondly, you don't want to spend time Googling things. You're cheating and you're wasting time. I'm not sure which is worse. I am sure which is worse. Cheating is worse. But wasting time, you will punish yourself for. So don't do that. And then you need an example of standard deviation. And you need to understand how to use the formula. Because I presented it. I gave an assignment. Turned out badly. I sent an email. I gave an assignment. I graded all of those today. You should know how to do a standard deviation. Why? Because it's how we handle sig figs and averages. And we will continue to do that this year and in Chem 1B.
Is there going to be a density related conversion?
There could be. Honestly, I can't remember. But absolutely, to get from a volume to a mass or from a mass to a volume, you need density, and that should be on the test. If it isn't, I've done a bad job. So I am trying to be as transparent as possible. Why? Because I want you to be prepared and successful. But you may have questions I haven't answered. So any questions out there?
Yeah, so I had a quick question about the standard deviation assignment that we had. So in the email that you sent out, this was before I did it, but you said one of the biggest problems that like most people made was they divided when they were doing the problem, they divided by 4 instead of 3. I wasn't sure if that was a typo, but.
No, that was the biggest problem.
Okay, but why would you divide by 3 though?
Okay, I'm glad you asked.
Yeah.
Okay, so let's say, for example, that you have all the pennies in the world and you want to find the standard deviation. If you have all the samples or the replicates, so you have data for data for everything, then you can find something called sigma, which is the standard deviation, and that is the square root of the deviation squared divided by all the samples. But you didn't have all the pennies in the world. What you had was a subset. So if you don't have all the replicates, all the trials, every time that could be done for everything, then you have a subset, and that is normally going to be true. And if you have a subset, you come up with a standard deviation that is equal to the square root of the sum of the deviations squared divided by n minus 1. When you divide by n minus 1, you're dividing by a smaller number. So when you divide by a smaller number, you end up with a larger S. Why is that important? Because a larger variance makes sense if you don't have every example. You're kind of hedging for the fact that maybe the subset you got didn't include some extremes. And so in our class in Chem 3B and Chem 1B, and in Chem 5, analytical analysis, like the class you might take in your second year of chemistry, this is the formula we use. But if you Google standard deviation online, you might come up with this formula. So I suggest that you just read everything I give you and watch all the videos I make for you, that I labor, that I spend time, that I video and edit for you, so that you understand in our class. But I love your question, Christine, because what you're asking is what's the difference? And the answer is, this would be the example of if we had every trial, and that's usually not true. Normally we just have a subset. So we have to have a little more larger standard deviation to allow for a little more deviance. But if that doesn't make sense, I hope that you will ask again. And if in my talking, somebody else went, what? And had a question, feel free to ask your question. I love that there's 7 of you with videos on it. It's awesome. Thank you so much.
So it's basically for smaller samples?
For a sample that isn't every replicate. We call that a sample set. If it's a set that represents a larger group, this is the correct way to do the formula. In science, especially the beginning, you're not going to have a set that represents every replicate, everyone in the group, because that's nearly impossible to do.
Do you mind doing a quick one, quick example? I mean,
standard deviation? Sure, why not? What do you want to do? The mass of a penny? Love it. Great idea. Here we go. So let's say that you have some masses, and mass 1 is, what were pennies again? 2.5? So I'm just going to weigh out 3 pennies, which is a very small subset of all the pennies that there are. The first thing I do is come up with an average mass. And when I do that, I'm going to report all the digits my calculator gives me, because we're not going to round until we get to the place where we report the answer. And I'm doing this on the fly. So if somebody gets a different answer that they're confident in, and you're like, Stu, go ahead and tell me. So now I want to find the standard deviation, and that is the square root of this ratio, the sum of the deviation squared divided by n minus 1. And n is just the number of trials. Since I had mass 1, 2, 3, 3 minus 1 is 2. I'm going to do the deviation squared slowly, but I've learned how to do very quickly on my calculator. So let me do that quickly first. And I'm going to tell you how to do it. And if you're tracking, this might be useful. So I'm going to put store in place 1, that average. And then I'm going to say minus the first value, 2.5168, hit equals and square it. And now my pattern is just going to be the number that was stored. So I'm going to recall, and I put it in place 1. Recall 1 is just this average, minus mass 1 equals, and then square it. And so now I have the first deviation squared, plus parenthesis, recall 1, pull up that average, minus mass 2, close, square. I don't have to hit equals this time, because when I close the parentheses, it does the operation. Plus recall 1, minus mass 3, hit the squared key, hit equals, divide by 2, and then take the square root. Okay, so I can't see your faces, and I don't know, should I continue on, or are there questions? You want me to wait a minute?
What was the button you hit at first to store it?
STO.
Did you hit it before or after?
Melissa, do you have this one?
Yeah.
Okay, so just type in your average, 2.5291333333. Once you have that number on the screen, hit stow and then pick a number. I'm going to put it in box 1, so stow 1. Now, every time I hit recall 1, that number will pop up.
I wasn't hitting the 1, so it wasn't.
Yeah, it doesn't have to be 1, but you have to pick a place to put it and recall it from that place.
Thank you.
Yeah, definitely. Other questions? I see of the 6 heads that I have, 5 of them are looking down, so I don't know. Go on, slow down. Questions? Bobby, how you doing?
Yeah, do you have your calculator in degrees or radians when you do this? Because I know sometimes you would switch
Degree?
when doing calculations.
Degree.
Degree? Okay.
I think radians, aren't those for circles? If you're working in polar coordinates, that kind of thing. That's math. I took it 30 years ago, but I believe I remember that.
Thank you for showing that.
Yeah, totally. It was Bobby's question. That was a great question. But we're not done. Because, say on the exam, you're going to have to report the average. How do you do that? Shall I show you? The correct answer is yes. Okay, so I have an average and I have a standard deviation. Great, we're halfway there. What do? We round the standard deviation to 1 sig fig. Why? Because You learn to count before you learn to add. You learn to add before you learn to multiply. You learn to multiply before you did exponents. There are steps that you do, and this is the appropriate next step. So I'm going to round it to 1 sig fig. My standard deviation is 0.03 grams. It has the same units as the average. And then because my standard deviation is in the hundredths place, that's the place around the average. My standard deviation is saying that the numbers start to vary by 3 in the hundredths place. That's like the last semi-reliable place. And so because that's a 2, I look to the right, I see a 9, that tells me to round up. So for my final answer, the average mass is 2.53, because I rounded up, parentheses, plus or minus 0.03, and then both of those have units of grams, so I put that outside the parentheses. It varies by 0.03 grams, either higher or lower. And since that's in the hundredths place, my average is 2.53 grams. Questions?
So wait, the average, you show 3 significant figures because, sorry, I said.
Madison, can you talk more toward your mic maybe? Say it again.
So the average has 3 significant figures for the final answer because
this one has 3 sig figs in the final answer. Why? Because when we calculated the standard deviation, the place it varies is by 3 in the hundredths place. And so the hundredths place is as far right. It's like the estimated digit for the average. It's as far right as we can go.
So you see how many places over it is for the deviation, or not the deviation, the standard deviation, and that's how many over you go over for the average.
If you mean by over, you mean to the right of the decimal? Yes. Are we good?
Yes.
Okay, good. Other questions? So Bobby, Courtney was the first hero of the day coming in with problem 132, but you are the current hero of the day because I think everybody wants to see that one more time to have it submitted before they see it on their exam. So good job.
So Sue, I think I just realized that I've been doing calculations wrong. Is there any way I can submit that second worksheet a second time after I try to fix it?
Are you talking about standard deviations too?
Yeah, I am.
Yeah. It's not due until Tuesday.
So I can resubmit it though?
Unlimited. You
awesome.
Can submit it every hour from now until Tuesday.
Okay, cool. Thank you.
Yeah, and I will grade the most recent one.
Awesome.
Yeah. Other questions? I don't know if you're all here. You're so quiet. So it's interesting, the SurveyMonkey, I got some feedback. And one of the things was the discussion boards, like when we met together in breakout rooms to do a Jamboard, was problematic for some people because students didn't participate verbally or have their video on, and that was frustrating for the students that did. Oh, I feel that so much, so much. Yeah, that's a problem. The next thing was some people didn't want to have to come to Zooms and watch them. And that I don't even know what to do with because, you know, come to class or don't at your own peril. And then the next one was students, this was kind of consistent, wanted to have more lecture in Zoom. Less time on the Jamboard, more time with lecture. And when they did the Jamboard, they wanted answers, which I get. That totally makes sense. One person said they needed more instructor time in Jamboards, and I feel like I am only one person. Do you understand how many plates I'm juggling? And then I reminded myself, how can you? Like, you don't know how hard I'm trying and how difficult this is, just like I don't know how hard your situation is. So I hope that this 20 minutes of lecture has been helpful. And now I'm going to move to the content. And as far as the Jamboards go, when you go in there, if you could turn your video on, I think that would really help the students who are trying, who are earnest, who are good colleagues to you. And then if you're not going to participate, you know, instead of just leaving your name up on the screen, just check out. You know, that's fine, but be present or don't be present. Don't pretend to be present. That doesn't help anybody. Doesn't help you. Doesn't help anybody. Okay, was that too harsh? I don't know. Maybe. Here we go.
If we get the Jamboards wrong, but we like gave it our best college try, like what happens? If you look at it and it's like
the whole point of problem solving. So that's one of the big shifts that I have. Like that's one of the big things we have to deal with. Me as the instructor, you as the students in their first chemistry classes. You have been raised, most of you, in a public school environment where like good if you're smart and fast, and good if you get everything right. But that isn't science. That isn't even life. Life is, did you show up? Good for you. Did you show up and give your best? Even better. Did you show up and give your best and it was good enough? Woohoo! Excellent. Because that is not most days. Science is showing up and doing your best and learning from your mistakes. And so on some days you show up and you're the leader in the Jamboard and you get them all right, and that's excellent. And some days you just come because that's the best you can do, and that is still excellent. Because life is about raising the percentages. Okay, so now if you don't like the Sue stories, just check out. In 5 minutes, come back. But I'm going to tell you a Sue story. And the expression is raising the percentages. So when I was in high school, just incredibly insecure and, you know, typical, I don't know, misplaced person. Like I didn't know where I fit. I was in a choir, and the choir director, who was a great man, he was my voice teacher. He'd give me some voice lessons. And one day he said, Susie, the sound you just made, that's opera quality. And I was like, what? And he goes, so I know you can do it because you did it once. The difference between you and the person who does that professionally is just the percentage of time that you do it. And when you practice, you're raising your percentages. And it was just like, oh. And then I never became a big singer. I mean, I sang with a band, but who hasn't? But I took that idea with me. Practice makes us stronger if we're willing to be honest and learn from our mistakes. But you have to be okay with making mistakes. And you have to be okay with wasting time sometimes. It's not really wasting time. It's the process of discovery. And I am a very impatient person. So I didn't like wasting time and I didn't like making mistakes. But what I realized as a very old person, and I could be your mother or your mother's older sister, like engaging is the important part, and growth can happen. If you decide what you want to be, you can become it. But showing up is a big part of it, and doing the best you can is a big part of it. You have to be okay with some days are better than others. So yeah, Melissa, about showing up and doing a Jamboard and getting them wrong. I have emailed groups of students just to say, oh, I saw a thing on your Jamboard and this is what you need to know because it wasn't right. It wasn't like I'm judging them. I just don't want them to go on thinking it was right when they had an opportunity to learn something. So it is really just about being the best you can in the moment for growth. And you wouldn't be at community college if you didn't want to grow. Like you're taking time. This is not easy. Taking chemistry. Who does that? You know? And I don't want to diss on communications because there's an art there too, but it's a lot easier to stand up and talk to people than it is to do these problems. So you pick this because you're curious people who love science. And every day you show up, I'm proud of you. But if there are people that aren't really engaged at this point, I feel like, fine, don't show up. I'm not going to keep track of your Zooms and I want you to pass. But if you're not engaged for you, I'm going to spend my effort being engaged for the students who are present. And I'm not going to worry about the ones that float away, which is really hard for me. I lose sleep about that. Okay, come back if you were gone. So we're counting particles. What does that mean? We're considering what isotopes are. So some of you who have participated in Jamboards where nobody has their video on or will talk, do you understand how hard it is for me? I'm used to talking to an audience of at least 50 people. And here, they can't not be engaged. Like I will walk up to them and hand them a banana. I am right in their face. Do you understand how hard it is? I'm just doing the best I can and hoping. Right now I have tears in my eyes.
Well, you're doing a great job, Sue. I appreciate you.
I do
Yeah,
too.
we appreciate Sue. Thank you.
Thank you.
Oh,
Oh,
exactly.
there's Luke. Look, it turned on his video.
All right, I was eating dinner. All right, so give me like 10 minutes.
Hi, Luke. I'm glad you're here.
Hello.
Okay,
Hello,
so isotopes. So there's elements, and we talk about what is the smallest unit of an element. It's an atom. Once you get smaller than an atom, you're not talking about an element, you're talking about matter. Protons, neutrons, and electrons, those are just the things that make up matter. But as soon as you get a certain combination of them, you can call it an element. So for carbon, which is the poster child, carbon has 6 protons. Every atom that has 6 protons is carbon. But it turns out there's 3 flavors of carbon. There's the carbon that has 6 protons and 6 neutrons. And we call that carbon 12. And sometimes we just say C12. Because we're big about saving ourselves energy. We don't want to waste energy unnecessarily. Now, when we talk about an atom, we're talking about a neutral particle. So to be neutral, if it has 6 protons, which are positive, it has to have 6 electrons, which are negative. And this week, we're only talking about atoms, but next week we'll talk about ions, which are incredibly important. Okay, so every carbon here has 6 protons, and because it's an atom, it has 6 electrons. But the number of neutrons determines which isotope it is. So isotope is like a flavor, a kind of this element. And there are 3 kinds of carbon that exist. 2 are stable and 1 is radioactive. It's not stable. So the carbon that is called carbon 12 has 6 protons and 6 neutrons. So in the nucleus, there are 12 particles. The number of particles in the nucleus is called the mass number. The number of protons and the number of neutrons, you add it together, that's the mass number. It is a little confusing because the mass number is not a mass. It just counts the number of nuclear particles. The only particle that isn't in the nucleus are electrons. Electrons are outside the nucleus. Okay, the second kind of carbon that exists and is stable is called carbon 13. Well, if there's 6 protons and there's 13 protons plus neutrons, there must be 7 neutrons. So carbon 13 has 7 neutrons. Okay, this last kind of carbon is not stable. Warning, warning. Carbon 14. And this is the carbon that they use for carbon dating, because carbon 14, something about having 6 protons and 8 neutrons is not stable. And so this is the one that will spontaneously turn into a different kind of element. It breaks apart. Okay. So when we're talking about isotopes, we're really talking about stable isotopes in our class. Carbon 13 and carbon 12 are stable isotopes. But an isotope is just a kind. When you look on the periodic table and you see something like this, carbon has a 6 above it. That's the number of protons, that's the atomic number. And then it has a number that has a decimal, 2.011. That number is important, but not this week. That number is an actual mass, it's not a mass number. And we could say that there are 12.011 grams in a mole of carbon. If that makes any sense, if you've had chemistry before, and if you haven't, don't even worry, we will talk about it. Or you could say that every carbon atom has 12.011 grams, or I'm sorry, AMU. Per atom. But the truth is that this is a lie. There is no cake. The cake is a lie. There is no atom of carbon that has a mass of 12.011 AMU. There is no group of carbon called a mole that has a mass of 12.011 grams. It's a weighted average. Questions? Anyone? Okay, so we're not talking about weighted averages today, but for the rest of the semester, we'll spend a lot of time talking about those, but not today. Today, we're just talking about particle counting, and this is what your Jamboard looks like. I have given you the thing to fill out, a grid here. Maybe don't make it quite as large as that, because later you're going to want to check it against the key, because you asked for answers and I'm delivering. And then the more of you that can turn on your videos and turn off, like unmute yourselves, the better it is for the group. It will help you and it will help the people who are helping you. Any questions? Okay, when you're done and you can leave, but I'm going to put you in breakout rooms now.